So welcome back to the video. Till now we have covered about the OSI model, Cisco basics, ARP architecture and layer 1. So now we are going to study about the IP addresses. So we will be focusing on IPv4 addressing, and this is the part 1. So stay tuned for the next part consecutively. So now we'll take a network which is like having 2 switches and 4 PCs over here, and let's say this fall under like a network 192.168.1.0.0/24. So this is a network over there, and then we'll look around like a similar kind of network, so like many types of networks. So this is like another network which is separated by a router, and then we have like two separate networks, that is 168.1.0 and then 192.168.2.0/24. We'll cover everything basics, like what is the blue part, what is the light blue part, and then what is the slash notation and all. So we'll cover in detail. So basically the first question can be asked by the interviewer or by anyone is like, what's the length of the IP addresses? So IP addresses are typically 32 bits, that is 4 bits in length, so 4 bytes in length. So you just need to keep in mind what is the size of the IP address. So what is the dotted notation? So they are divided into 4 parts, so each part is like 8 bits, so 8 times 4 is 32, and then they are denoted in binary. So what is binary thing? It's like nothing but it's like a scale of power of 2 thing, and then you just add like just to make up the number, you just add 1 to 1 in that place and you will get up the number. So for the simple example is of 0, so 2 power 0 is 1, and then you just add 1, you will get 1. So similarly 254 can be like adding all the ones, like having ones in all the places, and then the sum of all is like 254. So basically they are divided into 4 octets. So this 192 is like 1 octet, 168 is second octet, third octet is 1, and fourth part octet is 254. So coming to the next part, so what is /24? So /24 means like the first 24 bits, that is 8 3s are 24, like 192.168.21. the first 3 octets, like 24 bits are of host, and then rest whatever remaining like 32 minus 24 is like 8, those belong to the host. So in this way we are able to analyze the block size and all. So we'll just cover in everything in detail. So as I said, first 24 bits belong to the host and the rest belong to the first 24 belong to the network, and then rest to 8 belong to the the host. So we have seen like this network ranges from 1 2 till 254 hosts over here. Similarly goes for like 2.0 network. So we'll just cover everything in detail. So let's take an example for like /16. So make a guess like how many bits will be in the network and how many bits will be in the host part. So as I said 16, so we can see /16, the first 16 part like the 154.178 will be in the network part, and then rest whatever is remaining, the rest 16 bits will be in like the host part. So let's take an example for /8. So similarly we can see like first 8 bits will be in the network part, and the rest whatever remaining 24 bits will be in the host part. So you can see over here in example. So basically what is IP address? IP addresses are divided into like the 5 blocks. Basically the first is like class A, and then the range is like 0 to 127. So class B, the range is from 128 to 191. Class C, the range is from 192 to 223. And then the class D, which is reserved for like multicast addresses, these are being used in case of like the OSPF addresses. We'll cover that topic very soon in the next videos. And then class E is being reserved for the experimental experimental practices and all. So basically what class A, B and C is like, as per the requirement of the client we design the network. So depending on the number of hosts we see, we take the class of the IP addresses. So at home you might have seen like 192 like 192.168 addresses, but if you go to some any campus or like a corporate job or like a corporate job places, you will see your IP in like 10 dot something or like 172 dot something. So basically you just need to remember, like depending on the availability of the host or like the client's requirement, we decide what class of the network we should be opting. So the first class which is being like uh, 0 to 127, it's not actually in like 0 to 127, it's like 0 to 126. Why not 127? I'll just tell you. 127, the address range is being reserved by the loopback addresses. So what is loopback addresses? Loopback addresses is nothing but it is used to test the network stack, that is the OSI or TCP IP model on the local device. So it is nothing but the address of the device itself. So let's take an example like a router ID or like something like that. Router address is different thing, but loopback address is like a address of that device. So let's say I have just ping 127.0.0 or 0.1. So over here we can see like the 5 pings are being taken successful, and then it has completed the round trip. And then let's take one more example like 127.23.68.241, and then we see like the trip time takes 0 seconds. So what does 0 second means? So it means like it has been pinging itself, so it's not going anywhere. So that's why we can see a 0 seconds over there. I hope this loopback addresses concept is clear. Now we'll just see the classes over there, and then let's see the prefix length, what is like /16 /8 /16 and /24 for the class A, B and C. And then so as we can see, as I told you before, like /8 means like first 8 bits are being reserved for the network, and then rest of the things are being reserved for the host. Similarly in 16, first 16 are for the network and the rest 16 are for the host. In /24, like the first 24 bits are for the network and then rest 8 are for the host. I hope this is clear. And then this comes under like class A, class B and class C, like you can see over here. And then you can see like we can accommodate, as I told you before, like when you go in college there are more number of students over there. That's why we can have this many number of hosts accommodate in that network. So since we are at home and then we get IP in like 192 network, as I told you like over here, so that's why like in our home there are not much more devices, like maximum of 40-50 devices we can have. So 256 hosts are enough for our network. So what is like the subnet mask or like the net mask over here? So subnet mask is being denoted in like binary itself. So we just need to know what is /16. So what is it's been denoted like /8 /16 and /24. So it's for /8 it's like 255.0.0.0, then like /16 is 255.255.0.0, and then for /24 it's like 255.255.255.0. so yeah, so as I told you before, the host portion of the addresses is, if the host portion of addresses is all 0, it's called the network addresses. So in this case, if we take the first 24 bits and then rest 8 bits which are 0, that's called a network address, and then it can't be assigned to any host. So this is very important. So basically this is being used to like call the network, and then if the host part of the addresses is all ones, then it's called a broadcast address. Broadcast address means like it's being uh, asked to everyone. So that's the thing, and even that address cannot be assigned to the host. So I hope this network and broadcast addresses are being clear. So that's why this is the thing we need to study. And then yeah, thank you. And then stay tuned with me for the next part. We'll cover the practical configuration on the router in the Cisco packet tracer, and then I'll let you know more details. So stay tuned for more 2 parts. Thank you.